Okay, hello everyone. It's weird. It's a little yellow line. I don't know if y'all can see it on the video. I think I'm recording both the window capture and. Oh, okay, I was. There you go. I guess now you can see everything. That's interesting. Wait. Huh. Okay. Oh, just like layer by order. I'm learning OBS on stream or on video. Anyways, sorry. Hello everyone. Today is Thursday, July 3rd, the day before Independence Day in America. Today is 9:57 p.m. or right now it is 9:57 p.m. and we are going to continue on with dynamic programming. It's late tonight. I kind of stay a little bit later on work, just to get some extra stuff done before the long weekend, and just kind of brain rotting on Instagram for the time being. I genuinely need to delete Instagram so that way I can have my time back for my day, because I feel like I'm spending way too much time on that. But sorry, disregarding that, let's look into our problem. So today we're going to start off with min cost climbing stairs. So you're given an integer called cost. The cost of I is the cost of the ith step on a staircase. To be the cost, you can either climb 1 or 2. Huh. Interesting. Okay. So we will make our cache here, and then I'm going to do FDP. We're just going to call this step. Okay, this is not JavaScript. Gotta lock in, brother. So if step not in cache, then I do my stuff, and then I'm just gonna return cache of step, right? So that's how you typically go about it. So each index in cache will hold the step and then like the associated value of the minimum cost it would take. So, for example, the minimum cost for 1 is 1. The minimum cost for 2 is minimum cost for 2 is 1 as well. You could have an instance where the minimum cost for 1 is like 100, and the minimum cost for 2 is 1. You can start with that order. So we're going to say cache of 0 equals cost of 0, and then cache of 1 equals min of of cost of 0 and cost of 1. Oh, I see. You have to go past it. So, okay. It's not enough because the for second half, the cheapest one should be 10 and then jump 2. And then you get at the end. No, you need to go beyond the array. Because you're going to take the cost and then go beyond. Okay. Oh, hey, big guy. Hello. Hi, kitty. Oh, hello. Hi, buddy. You're so sweet right now. Are you so sleepy? Your ears are so sleepy. Cat loves to start trying to level on me while I'm in the middle of my video. Typical. Okay, so I need to draw this out. You know, I used to make recurrence equations or whatever they were. I used to do that like it was lunch, like it was no problem at all. It was an academic weapon. I was back in fall of 23 and spring of 24. That entire year, I was like cracking out on my mathematics for my theory stuff, and then this past year I just been mainly focused on project stuff. I kind of threw all that stuff away. Honestly, if I started this journey like a year ago, I probably would have exceeded much more than I'm doing right now, because I'm kind of tooting out on what I would call, this is probably a very easy problem for me whenever I was actually doing this stuff. But now I'm washed. Now I'm sitting here and I'm having to draw it out. Let's see. We have 10, 15, 20. We have, I'm going to call this the end. So from the end, I can either do take the cost of this 20. Actually, I'm not going to use a circle. I think the circle is going to confuse me. I can either take the cost of the 20, or I can take the cost of the 15. Right? And then from the 20, I can take the cost of the 15, or I can take the cost of the 10. From the 15, from 15, I can either take the cost of the 10, or nothing. Right? And here you go. The cost of the 10. Or I can take the cost of nothing. And from the 10, So basically, I can go from nothing. I start from in, and then I need to get to end. So 0, 15, end. Right. This is my solution here. Okay, but this is cut and dry. This is just kind of like one line, right? But it could get pretty. It can get pretty tricky. Something like this, where now I have multiple things to look at. So I can, from end, I can go, I can do 1, or I can do 100, right? And then from 100, I can do 1, or 100. 100, I can do 1, or 1. Oh! I think you just choose the minimum, right? Let's say 1 is going to equal to dp of step minus 1. 2 is going to equal to dp of step minus 2. And then I'm going to say cache of step is equal to the minimum of 1, 2, plus the cost of the current step. And I'm going to do return dp of length of cost. I don't think that's right. Well, length of cost is one step over, so. Oh, right. Yeah, yep. We're out of bounds. Yeah. I can see that being the problem. Ooh. See, but the thing is, like, I don't have to take the current thing. Which is why it's so tricky. I don't have to take. How do I properly do this one? See, whenever I was looking at his solutions, he was doing from like his top-down solution was a bottom-up solution. I don't agree with that. To me, that's just tabulation, but with recursion. I disagree. This is the solution I was looking at yesterday with his regular climbing stairs. Okay, well, I guess we'll do what we gotta do. I don't like that approach, though. Hold on. This just isn't it for me. Not gonna lie. I don't like this approach at all. I can do it. I can do it top down. I know that it's literally possible. I just gotta figure out how to do it. Alright, whatever, man. Guess we'll have to do it the other way. I disagree heavily, but I can't really come up with a process that actually works better, so can't beat them and join them, It's gonna piss me off. Still doing this stupid ass if it's in the cache or not, man. I have to do it because that's DP. Ah! Okay, so, like, why am I not thinking properly right now? What? This is pissing me off. I hate bottom up, bro. This is bottom up, bro. You can't tell me this is not bottom up. We are starting from the bottom and going up. Just because we're using recursion does not make this automatically top down, brother. What? I don't know. I'm probably wrong. I'm most definitely wrong. He was working at Google. He knows what he's talking about, but this is not even close to how I was taught. And now I gotta figure out the proper way to do this. Oh, I'm very certain there is absolutely a chance that I can do it with this, because I've used this type of recurrence for problems that were way more confusing than this one. I'm just not seeing the method right now. Wait. Hold up. Really? Oh. Yeah. Interesting. There you go. Okay, nice. And then I have to do the solution that I hated, so win-win for me. I just think, to me, it's more intuitive going recursively like that. That's how I like it. I like to do my problems. House robber. I'm pretty sure this is a very popular one. I am a professional robber. Huh. Planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So your decision tree here is you can either ignore and move to the next one, or you can take and you have to skip the next one. Those are your decision trees. So you either move up one. It's a 1-2 movement. Same thing with the stairs, except moving one means you take. I guess. Sorry, no, moving one means you don't take, but yeah, you can only move one if you don't take. Actually, that's true. And then moving two is if you do take, and technically I don't have to check that for not take because you can hit that without taking anyways. I don't know if that makes sense. Like if I go from 2 to 1, okay, so if I take 2, then I can go to 1. If I don't take 2, I go to 3, and then I can go to 1 anyways. So like, there's no point in including that into my recursion because it's already going to be included later on. So I only have a 2-step system here. So I'm gonna set a cache here. I'm gonna make my name as bland and boring as humanly possible. I'm gonna say if house in cache, if house not in cache, then we need to find house. Else we're gonna return cache of house, and my two choices here is I take and jump 2, or I don't take and jump 1 are my 2 options. So I'm going to call this take. That's going to equal to dp. Because I'm doing this. I'm going to have to probably... This one probably have to actually do bottom up. After all my yapping just a second ago, I'm going to have to do this bottom up, I believe. Ooh. Actually, no, I don't have to do this because it doesn't matter the adjacency. It's either way, you know. Adjacency's either way. Okay, we'll do. Take is going to equal to dp of house minus 2 plus nums of house, and that's take. Don't take. This is going to be equal to house minus 1. And we want the maximum, so I'm going to say cache of house is going to equal the maximum of take versus don't take. And we're going to have to do an edge case here. We're going to say if house is less than 0, then return 0. And cache of 0 is going to equal nums of 0. Okay, so I don't know if this is gonna work, but we will see. So it's gonna be length of nums minus 1. Let's try that. Right. Return. Nice. Okay, perfect. That passed. I don't know why that one was easier than min-cost climbing stairs, but whatever. House Robber 2. Ah, crap. This makes it actually a lot more difficult. How do I check this one? See, I could add in an extra base case, but that's just not smart. Okay. So I mean, it's basically saying I can do that, but that creates extra space complexity, which is not what we want, you know. I'm guessing the space complexity, what it's supposed to be, is just O of n. Yeah. Okay, so that's what we do. We do create two arrays. Okay, alright, interesting. I'm gonna call it solution 1. Of 1 and onwards. Uh, eh, I'm not. I'm not really feeling this one. I'm feeling doubtful, but we'll see. Okie dokie. Let's say this is the house, and then this is the neighbors. Just do a kind of a cute thing of just checking the neighbors. So. Cache 1. Cache 2. See, I don't like this. I don't like this. I don't like this. Crap. Okay, you know what? I have an idea. I'm gonna keep one cash. I'm gonna say where do I get out of that? Hold me down, I feel sweet from the edge, and I'm thinking. Okay. Alright, let's try this. If house is less than 0, then we just return 0, and then if house not in cash, we'll find it, else we'll just return cache of house. And I will do, to find it, it's just what we just did previously, which was take equals dp of house minus 2, we're going to include neighbors on this, plus neighbors of house, and then don't take, it's just going to equal to dp of house minus 1 neighbors, and we will get the max. We'll say that the current thing will be the max of either we take or we don't take. Okay. Okay. I don't think this will work. I think this might actually cause an error. Interesting. Where do we get this 5 from? It would be impossible to get a 5 regardless of whatever method we do. How the hell did we get this 5? Oh, I see how we got it. Actually, no, I don't. I still don't see how we got it. How the fuck did we get this 5? Ha! Alright, bro. GG's. Oh, no, I do see how we got it. Alright, well, whatever. Let's submit it, see if that runs or probably doesn't. Runtime error. List index at a range. No. No. No, 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 no. Boy. You know what? I'm a lazy man. If length of nums is equal to 1, we're just going to return nums of 0. And you know what? I'm probably going to do that if length of nums is equal to 2 as well. Sorry. Oops. Hey! There you go. There's house robbers. Was that 3 already? Didn't want to roll. These are way quicker than the graph problems. Yeah, dude, this is gonna cook me right here. 2D DP and advanced graphs cook me. They're gonna cook me. I ain't gonna be able to breathe. Bit manipulate, dude. This right here is like the holy grail of actually gonna get me fried. Like these 4 are actually gonna beat me to death. Greedy, I mean, I don't know. I mean, it's far down here. It sounds like it's gonna be harder than it is, but like anytime I've done greedy's always been stupid easy. Maybe I'm missing out though. Maybe there's like actually quite a bit of difficult ones. See, there's no hard, there's no easy, but I don't know. I mean, should I try another one or should I log out? Given a string S, return the longest palindromic substring? Rather what? Palindromic? Oh, dude, I was about to be like, I know what a substring is. Okay, so it's just... Okay. Alright, that makes sense. This is where DP starts to get challenging. Those counting ones are pretty easy. But this is where it gets problematic. I think I might save this one tomorrow. Because I still got a bunch of stuff to do. I might think on this just for a second though before giving it a quit. So, first, we'll start off with. We did something like this in the backtracking, and I did it pretty quickly too. But I think I used a hint in order to get that done. We'll see. So we'll start off with the n. We'll say we're given access to D. Ooh, wait. You know what? Let's see. What's the time on this? Is it O of n or is it n squared? It's n squared. Yep. Okay, what is the rule of DP, dude? For the runtime, it's number of subproblems times the time it takes to solve the problem. So in this instance, it's probably going to be n subproblems, and it's going to take n to solve it. Dude, I gotta get back in my DP grind. I'm not cooking. Okay, so my idea is you have man, I did this one in my algorithms class. I remember this one actually kept me up. Like, this one was actually challenging to me a year ago. Who knows? Maybe things change. Maybe now I have a better understanding, but probably not. Probably not. My thought process is, because it's in square. I mean, like, respectfully, you can do a non-DP solution with n squared. It's good, but I can go like B. Oh, you know what? No, I can't. No, I cannot. Okay. Right, this is a DP problem. I am capping out of my butt. Because I was thinking you could just go find all the permutations, but permutations is factorial time, and brother, we do not want to do that. We do not want to do factorial time. 3 hints. How can you use a previously computed palindrome to compute a larger palindrome? I don't know, how can we? Mm-hmm. Ah, that's smart. Do you start in the middle then? No, because like... I think I'm gonna give this one to Tomorrow Me. Tomorrow Me, we'll see if we can figure out a solution. I'm having a little bit of trouble seeing where to go with this. You know, you can do B, then that, and then that, but like, not all the time it's gonna be in the middle. It's being deceptive putting it in the middle. You know, it could be on the left, it could be on the right. You never really know. Gotta think about the branches. I mean, a branch could be you take left, you take right, or you take both. Right. But yeah, no, I don't know. I'm gonna say that's gonna be a Tomorrow Me problem. But yeah, thank you for watching, and I will see you tomorrow.